Hello, my name is Wei Hao. My paper's topic is research on single-level cache replacement algorithm. Here's the introduction part of the whole paper. In today's computer memory system, the devices are in shape of a pyramid. The higher up the hierarchy, the more expensive and faster the devices are. And the lower down the hierarchy, the slower and cheaper the devices are. Then, when the data is used frequently, in order to make reading and writing faster, as we see in the right figure, data will be transferred from memory to cache. So, as the size of cache is limited, how to replace the data when the cache is full? This is the main research of this paper. The following are several common cache replacement algorithms. A total of first in first out, random, LRU, and LFU, 4 algorithms. First in first out is to replace the first in the cache data, and random is a random replacement of data. But these two algorithms are less effective. The LRU and LFU algorithms have a scientific basis and good results in practice. Then, I would like to introduce these two algorithms in detail. Regarding the LRU algorithm, the theoretical basis of the algorithm is that if a piece of data has not been accessed recently, then it is very unlikely to be accessed in the future. So we can set a counter for each cache, record how long each block has not been accessed, replace the largest block in the counter each time. For example, in the chart, block 1 has not been used for 5 seconds. Block 2 has not been used for 6 seconds, and block 3 is not used for 9 seconds. So according to the LRU theory, block number 3 is replaced from the cache. For the LFU algorithm, the theoretical basis is replace the data that has been used least recently. Then we can set a counter to record the number of times each block has been accessed. The size of this counter indicates how many times each block has been used in the recent period. When the cache is full, the least accessed data is replaced. For example, in the cache, block 1 has been used 5 times recently, block 2 has been used 6 times, and block 3 has been used 9 times. So according to the theory of LFU, block 1 is the least used block and it will be replaced out of the cache. In general, LRU and LFU algorithms can have good performance, but in extreme cases, LRU and LFU algorithm can be problematic. For example, a block is not referenced for a long time, but because of its high reference count, it continues to be held in the cache, wasting effective cache space. So how to solve the problem in this extreme case? This research proposed the LFU with dynamic aging algorithm, which is improved on the basis of the LFU algorithm. The algorithm sets a counter and age for each block. When the block is replaced, the age is set to the number of times the block has been used. And when a new block is put into the cache, the counter is set to age plus 1. This design solves the problem that a block that is not used very often but has a high usage frequency will occupy the effective cache space for a long time. For the model of the experiment, the cache receives read and write requests from CPU. I use the data on the right to perform the experiment. R means the CPU sends a read operation and W means the CPU sends a write operation. The cache simulator parsed the address string file and sent it to the cache model, finally to evaluate the performance of the 3 algorithms. The experiment test metric is AAT, average access time. It is an important metric for measuring the performance of a storage system, which indicate the average time it takes from issuing a read or write request to receiving data. In a cache system, average access time typically consists of several components: hit time, hit rate, and miss penalty. Cache hit time is the time it takes from issuing a request to receiving the data if the requested data is within the cache. And cache miss penalty is the time required to fetch data from the next level of storage when the requested data is not in the cache. And cache hit rate is the probability that the requested data is within the cache. Therefore, the average access time can be calculated using the formula in the figure. This formula shows that the average access time is determined by the weighted average of cache hit time and the cache miss penalty. To reduce the average access time, we can either try to increase the cache hit rate or reduce the hit time and miss penalty. This is the main goal of cache optimization. After experimental testing, it was found that the algorithm with the lowest average access time was the LFU with dynamic aging algorithm, which reduced the average access time by increasing the cache hit rate, and therefore it has the best performance. Thank you.